Okay, let's make a start. So like I said, we're doing iteration today. This is an algebra topic, and I'm going to kind of introduce to you, you know, different notation. There's notations you guys need to understand when it comes to iteration. Then once you understand that notation, the whole topic becomes quite simple, I would say. So there's something known as term-to-term formulae. So a sequence, so we know what a sequence is. A sequence is a list of numbers. Yeah, a list of numbers is generated using the following term-to-term formula. Now, x1 is the first term. Now, this is just notation for you. x1, the 1 is telling you the first number in the sequence. Yeah, x2 would be the second number in the sequence. x3 would have been the third number in the sequence. Sometimes they start at x0, but we usually do that at A levels. And GCSE, we like to say x1. So x1 is the first term. So have a look at this. It says x1 is 2. So x1 equals 2. What that's saying is the first number in the sequence is 2. That's what it's saying. So if x1 is 2, the first number in the sequence is 2. But then we have this other formula. It's saying xn plus 1 equals xn plus 3. Now, the interpretation of this formula is really easy. So we have n and we have n plus 1. Say n was the number 5. Yeah, if n was the number 5, then n plus 1 would be 6. So essentially what you mean, if I was to just kind of reinterpret what you're saying, is if you have n and n plus 1, then one of the numbers has to be even and one of the numbers has to be odd, because n and n plus 1 are consecutive numbers. Now, consecutive numbers means numbers that are next to each other on the number line. Yeah? So n and n plus 1 are consecutive numbers. You'd be right if instead of n, you said 2n. So 2n plus 1 would be the odd numbers if 2n is the even numbers. So we'll do this in December, but generally we say 2n is the even numbers and then 2n plus 1 is the odd numbers. So n and n plus 1 are consecutive numbers. Now, in the context of this formula, remember x1 meant the first term in the sequence. So when we say xn plus 1 and xn plus 1 is the next term in the sequence, and xn is the current term. So in English, what that's saying is to find, I'm going to highlight as I read, to find the next term in the sequence, all you do is the current term in the sequence plus 3. Yeah, I'll do a different highlight and I'll say again. To find the next term in the sequence, you do the current term in the sequence plus 3. If x1 equals 2 is the first term in the sequence, what would the second term in the sequence be? To find the second term, you're doing the first term plus 3. Well, the first term is 2 plus 3 is 5. Yeah? So guys, what would the third term in the sequence be then? To find the third term, you do the current term that we know, x2 plus 3. Yeah, so you do the current term plus 3. Current term 2 is 5 plus 3, so 8. Then the final one, x4, I said in the question, write down the first 4 terms. So the first term is 2, the second term is 5, the third term is 8. And by your explanations, you guys understand it, that to find the fourth term, you do the current term which we're on, which is the third term, plus 3. Yeah, good, which is 11. So as a list, it goes 2, 5, 8, 11, etc. Yeah? Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. And this is now where we get into the location of roots, which is what iteration is. So what are we doing? What are the roots? What do roots even mean? So we've done this already with quadratics, but finding the roots to a function f of x is to simply find the values of x such that f of x equals 0. Yeah, find where the function is 0. Another way of thinking about this is, where does the function cross the x-axis? Yeah, so we're going to look at all these different functions and we're going to use iteration to find where it crosses the x-axis. Now we have techniques such as the quadratic formula to find roots of a quadratic. However, what if we're given a function where solving it is extremely tedious, like a significant number of cubics? So if any of you lot decide to do A-level maths, we will be solving cubics, but a lot of that stuff is really long. I'll obviously, if you guys decide to do this, in fact, I'm doing a YouTube series on this already. If any of you guys are interested in learning a bit of A-level maths, then make sure you're subscribed to my YouTube channel. So we do have techniques to solve cubics, but they're really long and stressful and we don't learn them at GCSEs. But there are also other functions where we just don't know how to solve them at all. If I gave you x cubed plus 2x squared minus 3x plus 4 equals 0, the solution is that nasty looking solution. Now, no one's going to teach you that. That solution is known as Cardano's cubic formula. There is something known as a cubic formula. You guys know the quadratic formula. There is something called the cubic formula, but nobody learns it. You don't even learn it at A levels. That's known as Cardano's cubic formula. If you're interested, you can just Google it. But who has time for that? Yeah. And Ibrahim, it's not even difficult. It's just a substitution of numbers into a formula, but it's not even difficult. It's just who has time to sub numbers into a gigantic formula. Yeah, we just don't want to do that. In many cases, the approximate root, correct to a certain number of decimal places, is good enough for the calculations we want to perform. So for most stuff, knowing the exact solution is not useful. Knowing the approximate solution, correct to a certain number of decimal places, is good enough for what we want to do. And this is where iteration is really useful for us. Do you know that pressing the equals on our calculator helps us find approximate solutions where it's just a bit difficult to find the actual exact answer. So I'm going to show you how iteration works and what we're actually doing. So let's look at the equation f of x is x cubed minus 6x plus 3. It has 3 roots, but calculating them is not easy. Here's what it looks like. So x cubed graphs, remember we did this a couple of weeks ago where we looked at the shapes of cubics. This is what the x cubed minus 6x plus 3 graph looks like. Now, roots are where the graph crosses the x-axis. So guys, look at that diagram. If you look really closely, that root crosses the x-axis between 0.5 and 1. So let's put that down. Between 0.5 and 1. Where else can you see the graph crossing the x-axis? Between which numbers can you see? That's this one. Yeah, number 2. You can see it's crossing between 2 and 2.5. So the third one over here, I haven't put on the x-axis, but it's between minus 3. Yeah, between minus 3 and minus 2.5. Yeah. Now this is very significant because what is special about the function before and after we pass the roots? So what I mean by that is, look at 2. Look at the value of the function at 2 and look at the value of the function at 2.5. Yeah, look at the y values. And then compare that to, say, this one, minus 2.5 and minus 3. What do you notice about the y values? If one is above the x-axis and one is below, one is positive and negative. So 1, yeah, if you have the root, yeah, look, this is the root where it crosses the x-axis. On either side of the root, yeah, on either side of the root, one of the values has to be positive and one of the values has to be negative. Yeah? Now, why do we have to do that? Is because if one of the values is negative and one of the values is positive, then in between there must be a time where it's 0. Yeah? Which makes sense. Look up here, look at the 0.5. This one's above, so it's positive. This one is negative. So there must be a time in between where it's 0. Here, this is positive, this is negative. So there must be somewhere in between where it's 0. And the 0 is where the root is, which is what we're looking for. So what is special about the function before and after we pass the roots? There must be, so we say there must be a change in sign. There must be a change in sign. Meaning, one of the y values must be positive and one of the y values must be negative. So, to find where a graph crosses the x-axis, its value must be 0. So to even locate where that is, we need to find an interval. Yeah, we need to find an interval where one of the values is negative and one of the values is positive. So then we know 0 is somewhere in between. Yeah, so the root must be somewhere in between. Yeah. Okay. Now this comes to the last part, which is the exam questions. So how is everything that we've done going to help us find where the graph crosses the x-axis? Now it's a very simple process. It's called fixed point iteration. Okay, good, Ibrahim. It's called fixed point iteration. In the process of fixed point iteration, we do a rearranging. We rearrange f of x is 0 in the form of x equals something else. Then we use that new function of g of x to generate solutions using the iteration that we did at the beginning of the lesson. Let's revisit the function we've been dealing with so far. F of x is x cubed minus 6x plus 3. When f of x is 0, we can rearrange it to give you x equals 3 over 6 minus x squared. Now don't worry how I did that just yet. I rearranged for one of the x values in here. I rearranged for x. We're going to show it later on how I did that. Just take it for granted right now that I rearranged for one of the x values and this is what it looked like. Look at both of the graphs. So this is the graph we saw before. Look at where it crosses the x-axis. That is f of x. That's this graph. Now, where this graph crosses the x-axis is the exact same as where this graph intersect each other. Now, what is this graph? This graph is x equals 3 over 6 minus x squared. I've drawn the x graph. We all know what y equals x looks like. And I've just used a graphing calculator to sketch this 3 over 6 minus x squared. Now, in GCSEs, you do not need to know how to sketch that. In fact, in A levels, you do not need to know how to sketch that. The main thing you guys need to realize is that the roots of this function is the exact same as where these graphs meet each other. Yeah, and it's a very, very simple process. I've just shown you a lot of the theory because I always want to show you guys the foundations of where everything comes from.